y equals 2x, y equals x, and y equals negative 2x plus 4. Let's just look at the region first. Okay, so these two, y equals x looks like that. Y equals 2x is twice as steep. The only place they're going to connect is at 0. And y equals negative 2x plus 4. So if x is 0, y is 4. Similarly, this line has to go through 2 and go somewhere else up here. So I'm looking at this region right here. Let's see what these other 2 points are. My picture's probably not the best in the world. Okay, so y equals x and y equals negative 2x plus 4. Oops. Set them equal to each other. I have x equals negative 2x plus 4. 3x equals 4. So x equals 4/3. So this point is at x equal 4/3. Maybe. Now let's check when this line crosses 2x. So y equals 2x and y equals negative 2x plus 4. So now I have 2x is negative 2x plus 4. 4x equals 4. X equals 1. Okay, so this meeting spot is 1, clearly. So I'm going to put my generic x in here. Ooh, notice I have 2 things. I've got one function on top from 0 to 1 and another function on top from 0 to 4/3. So I'm going to keep that in mind. Right now I'm just going to put this here, call that x. So if I want the area, let's do that first. So the area will equal the integral from 0 to 1 of the top function, which is 2x, minus the bottom function, which is x, minus plus the integral from 1 to 4/3. Now the top function is negative 2x plus 4, and I'm subtracting x. Sorry, that's kind of messy. What to do next? So let's, running out of space. Let's do some volumes, and I'll try to make this picture pretty on the next page. So what we have. Not to scale. I'm okay with that. That's 1. That's 4/3. This is 2x, x, and that's that weird negative 2x plus 4. So, and there's my generic x. And I'll probably have another one over here, just so we have 2 of them. Now, if I rotate about the x-axis, then I'm going to have, let's see, so what I have, there's my y, there's my little thing, this little line is the little red line, so I'm going to have a disk, or a washer. So, integral from 0 to 1 pi, the upper circle has a radius of 2x, the bottom has a radius of x, so that takes care of the first chunk. Then I need to do the second chunk from 1 to 4/3. Top function is now negative 2x plus 4. Bottom function is still x. Okay, now let's rotate. about the y-axis? There's my little line floating in the air. If I rotate it around the y-axis, well, that's kind of lopsided. I have a cylinder. Cylinder is 2 pi RH. And we've got two different functions on top, so we have to break it up again. Integral from 0 to 1, 2 pi to put up front. And the first one, and all of them, my radius is x. In the first chunk, the height is 2x minus x. My second chunk, 1 to 4/3. Now my top function is negative 2x plus 4. Oh, and my radius, I worded that wrong. Okay, 2 pi. And from 1 to 4/3. Radius is still x. Now my height is negative 2x plus 4. Oh, you can't see any of that. There you go. Good, you didn't see my boo-boo. Negative 2x minus 4, and the bottom function is x. So that gives me the volume around the x-axis and the y-axis. Let's do it around some different lines. I need to draw this picture smaller so I get more on the page here. So, now you can see it. There's my x. Can you read that? I hope. Okay, so let's say I'm going to rotate about x equals 5. Now, I don't want to rewrite this whole thing. Let's see. We've got my little thing here. Here's 5. Here's my generic x. Oh, I can't draw very well. We have a cylinder. That's my radius. My height is still the difference in the functions. So cylinder, 2 pi RH. And I need to break it down into two because I got two sections. I don't know why I decided to do that. I'm regretting that decision now. So the volume is 2 pi integral from 0 to 1. My radius is 5 minus x. My height is 2x minus x. Now I need to go from 1 to 4/3. My radius is still 5 minus x. However, my height is now not going to fit on here. Negative 2x plus 4 minus x dx. Apologize for the squishiness. Same region. This time we're going to rotate around x equals negative 3. What's the difference? Before I try to draw another crappy picture, what's the difference? So here's my generic x. I'm rotating it around negative 3. There's my radius. That's supposed to be negative 3. Is right here. So the radius will equal x plus 3. So it's going to look just like this one up here, but instead of 5 minus x, it'll have x plus 3, or 3 plus x, whichever you prefer. So I don't really need to draw all that. I mean, I'm still going to have a cylinder. So my volume will be 2 pi integral from 0 to 1 of x plus 3 times the height, 2x minus x dx, plus 2 pi integral from 1 to 4/3 x plus 3 times negative 2x plus 4 minus x dx. So the thing that changes here is if your axis of symmetry is on the left or the right of your region, you're going to either have x plus something or something minus x, depending on where your axis is. Same sort of thing is going to happen when you have horizontal axis. Axes. There's that. So if I have the line y equals, I want to know what that highest point is. So let's just say y equals 5, because I know that's above it. So my picture will look like this with the prettier stuff. There's my 5. I have my little vertical thingy here. So when I go around y equals crap, the radius is going to change. And the question is, which one is on the outside? So here, I've kind of gotten rid of my pictures here, but imagine if I'm up here, then the outer one is the one furthest away from the axis. So the big radius, in this case, is going to be 5 minus the bottom function, which was x. And the little radius will be 5 minus 2x. This is in the first part. And in the second part, my big radius will still be 5 minus x, but this time my little radius will be 5 minus negative 2x plus 4. So if I ask for the volume, I have pi times the integral from 0 to 1. In this first section, I have 5 minus x squared minus 5 minus 2x squared dx, plus the integral from 1 to 4/3, 5 minus x squared minus the bottom one, which is 5 minus negative 2x plus 4, quantity squared dx. Now, how is this going to change if the line that we're rotating around is below? Let's look at that. So now the long radius is going to be used by the top function. And let's say I made that negative 3. So in the first part, my big R is going to be 3 plus the top function, which was 2x. And my little function, my little radius will be 3 plus that bottom, which is x. And in the second part, my big radius is still going to be 3 plus 2x, but now the little radius is 3 plus the negative 2x plus 4. And I'll just replace these in the appropriate spots up there. Oop, oop. So this video is already a little bit too long, and hopefully this part didn't get too confusing. This was a crappy picture. I'll do another example in another one. Might make it look a little better.